Hi folks, we're going to take a look at question 4C from the assignment sheet. So here we've got a triangle, which in and of itself is not right angled in terms of the information that's given to us. But if you draw the height of the triangle, we see that we've created two right angled triangles. So they want us to determine the height, but what they give us is this total distance between these two bases of the triangle. So this is a question we've seen a few times now. The only thing that's going to be different here is instead of working with the trig ratios and keeping them exact, I'm going to approximate them as I go along. Okay, so first thing is to realize that you can't solve this directly because you only have angles in the two right angle triangles. You don't have any side lengths. Okay, but you have these two side lengths that have a connection. They total 200. So what I can do is I'll call this side length X since I want to work with it. Need to give it a name. And this side here, instead of calling it something like y, I can just write it as 200 minus x. So we've set up a scenario where we've got two unknowns in our situation. Hence, we're going to have to create two equations. So here, if I start with the left-hand triangle, I'm going to have to work with tangent. So I've got tan of 47 equals the opposite over adjacent. And then here I've got tan of 42 equals the opposite over adjacent. Okay, and what I'm going to do a little differently here is I'm not going to keep the tangents exact. I'm going to approximate them. So here I'm going to solve for h in both, and let us write tan 47. Okay, now in order to get a good answer, we're going to need to keep 4 decimal places. So it's 1.072, I guess that's 4 times x. And then here I'm going to do the same thing with the tan of 42. Okay, so tan of 42 equals 0.9004 times 200 minus x equals h. Okay, and so now I can solve this system. Since I've isolated h, well, I know that I can just substitute this h here for this whole expression that I've got. Okay, or the other way around. Replace this h with that expression there. Okay, so let's do that here. So we've got 1.0724x is going to equal to this expression. Now, since I know I'm going to have to distribute that, why don't I do it while I'm going along? I still have the 0.90004. So first I'll multiply that to 200. Okay, so that gives me 180.08 minus 0.9004x. Okay, so here all I did was I distributed this to both expressions, and now I've got a fairly simple linear equation. So I'll bring that to the other side so I can collect all the like terms. So in fact, I know I'm going to have to add them, so let me do that right away. 1.0724 plus 0.9004 gives me 1.9728 equals 180, times x equals 180 times 0.8. So again, I just collected the x terms here. And finally, I just divide this out to get my final answer for x, 180.08 divided by 1.9728. And that gives us 91.3. Okay, however, x is not what I actually want. I'm looking for the height of this triangle, so I can just use one of these equations to find h. Of course, I'm going to use that easier one there. So h is equal to 1.0724 times 91.3. And that's approximately equal to 1.0724, 97.9. In this case here, it's meters. All right, so again, we've seen this type of problem several times. The only difference here is that I chose to approximate these two values so that I'm just working with straight numbers along the way. Of course, if I wanted something, even more accurate, although I'm pretty sure we would have gotten the exact same answer in terms of 1 decimal place, you can just keep these as exact numbers all the way through. Okay, that's it for this one.